All right, so let's do this again. This case, again, we have a side. We have a side B is 11, side A is 8. We're missing side C, and then angle A and angle B. So the way we start this is by first using our law of cosines to find the side C. So side C is C squared, right, equals A squared plus B squared minus 2AB times the cosine of C. So plugging in what I know, C squared is going to be 8 squared plus 11 squared minus 2 times 8 times 11 times the cosine of 37 degrees. All right, so at this stage of the game, it just becomes, I can put that all in my calculator. So C squared, right, is approximately equal to, so we got 8 squared plus 11 squared minus 2 times 8 times 11 times basically the cosine of 37 degrees. And so when I press that in, what we get is C squared is 44 point, it looks like, I'll just go ahead and keep all the decimals, 44, 401, 5023. So C, right, we do, when we take a square root, we do introduce a plus minus technically, but it is the positive one. So when I take the square root of that, right, what we get is 6.6663. All right, and so there's basically our side C, right, in 4 decimals. So we've got that part. So we know that this is 6.663. All right, so now we have to find angle A or B. Find one or the other, and then we use our sum to find the remaining one. So I got to do this one more time. So why not for angle A, right? So we know that side A, let me distinguish from the other, is equal to B squared plus C squared minus 2BC times the cosine of that angle. Again, the work's going to look very similar to what I just did up here, but I'll just do it one more time. Good to be able to push around variables. We get negative 2BC times the cosine of A is A squared minus B squared minus C squared. So dividing both sides by negative 2BC, right, we get that the cosine of A is A squared minus B squared minus C squared minus 2BC. And so our angle A is the inverse cosine of all that information in there. So side A is 8, right? Side B is 11, and side C we just found. Divided by 2 times B, which is 11, and then times C, which is 6.6663. So there's the exact answer right there. All right, but of course we'll go to our calculator and we'll just we'll put that all in. So again, so we're talking the inverse cosine. I've got a fraction, so in parentheses I've got 8 squared minus 11 squared minus 6.6663 squared, close my parentheses, divide, and then open up another set, and down below we have negative 2 times 11 times 6.6663. Close your parentheses, close them one more time for the inverse cosine, and we get our answer. So it looks like in this case C, angle C, or angle A, excuse me, angle A is roughly 46.2374 degrees. All right, and so we're almost done. To find my angle C, it's 180 minus the angle that I have, minus the angle that we just found. And again, just doing some number crunching. So 180 minus 37 minus 46.2374. That looks like our angle C is roughly 96.7626 degrees. So our angle A, our angle C, and our side C. Right? And again, that's pretty much going to be your routine. You're going to have to use the law of cosines twice. Once to find the remaining side, and then once you do that, you can find one of the remaining angles, And then once you find that, you can find the last remaining angle by using your law of the sum of the angles. If you wanted to, if you're sadistic, you could use the law of cosines one more time if you'd like. But it's much easier probably just to use the sum of the angles equals 180. All right, so there is the case SAS, side angle side. We'll cut off to a new video and we'll talk about how to do a side, side, side. All right, but that's coming soon.